All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Spear, you are indeed first. Only just as I saw the message come in. Nivy Me, how's it going? Good to see you as well. Welcome. So, what's on the agenda for tonight is to pick up where we left off last night in our sort of redux of all of the asset type. And specifically eliminating all of the individual handlers and simplifying our API for that, and nuking a bunch of code. And I think we're going to be able to tie up the rest of the asset stuff tonight, I'm hoping. And then from there, we're going to rework how resources are handled, which is going to simplify and remove even more code, which is going to be better. It's a change that I've been thinking about doing for quite a while since our last refactor loop, right? And so I think it's very much needed. Before we get into that, though, I'd like to thank the supporters of the channel, beginning with our elite partner, Javier Lazaron. That's the highest tier of subscription on Patreon, followed by our partners, Gabolis Inc. and Matt Osgard. That's the next tier of subscription there, followed by our supporters listed here on the screen that you see scrolling by now. They are a combination of the supporters on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated, and it helps me to offset the costs of running this channel and the project, things like software licenses, hosting fees, and eventually costs associated with actually building the game. So thank you all very much for that. It is greatly appreciated. All right. Let's see. Is it my Ortiv? Hello, how's it going? I'm not sure exactly how to pronounce that. But hello and welcome. I hope you're doing well tonight. So the last sort of handler that we have to change up is, I think, the shader. I think we've done all of the other asset types except for the shader. So this is the resource handler, which is sort of the resource level of that, and it now has, outdated resources or outdated references to the asset system. So we need to fix this up, and we can then go ahead and see if it builds. So the first thing that we're going to need to do is we're going to need to go to the asset system, obviously. And we want to go to the handler. Let's see. We want to go to the asset handler shader. And I don't think there's anything too crazy going on here. I think this is mostly just the release logic. So we're going to need a combination of this and then the serialization, which is actually not going to be very crazy at all, because that's all wrapped up in a nice, neat package. So the thing that I'm thinking, actually, let's go ahead and hop over to the header file real fast, because I think we can actually use maybe another one of these variations here as sort of a template. I'm thinking actually we probably are going to use, I think we could safely base this off of maybe the bitmap font. Actually, I'm thinking height map terrain is probably going to be the better version here. Maybe, actually, we can take material assets. Actually, is going to be a good one. We can base it off the material stuff. So let's actually go ahead and do that. Although we are only going to take the synchronous version of all this stuff. So let's actually just grab everything first. And let's see. Okay, here we go. Go down to the bottom here. And we're going to say shader assets, right? And I think what I'm going to do is do this and then do just kind of a in place, find and replace kind of thing. I'm just going to do this kind of all at once first. And actually, a lot of this stuff we're actually going to wind up getting rid of here in a second. When we get rid of all of the asynchronous stuff. And I'll kind of explain what my motivation is behind this in just a second. So the only reason I'm not doing find and replace sort of on the file as a whole is I kind of want to sort of validate what we're doing as we're going down through all of this stuff. Okay, so the release, I'm not going to necessarily worry too much about. That's going to be wrong anyways. So we're going to go ahead and fix that in just a second. Okay, so we actually don't need either of these things. Because we are only going to handle the synchronous version. The reason that we are not doing async on shader loads is because shaders are something that, like, as they're loaded, they're pretty much needed and like immediately after they're loaded. I can't think of a reason why we'd want to have that asynchronously done. Typically, you load your shaders ahead of time. Anyways, you load up all the shaders that you need. And if we had a custom one, like, we'd probably, when it comes to runtime, we would be also loading that up only when we need it. So I can't think of a reason why we want to do that asynchronously. So we're only going to support the synchronous loading of shader assets, which already simplifies our code. The other thing that I can do is let's just grab the release logic out of here. I'm just going to grab all this stuff, and we're just going to bang that right there. Right? And then let's see, we can do let's see, instead of this, let's just change this to typed asset, right? And then we can rename this to asset. All right, so that should be good there. Now the only thing that we'll need to set up is this function, right? Which is not that big of a deal. So a shader file is basically just a KSIN file anyways, but essentially we just perform a deserialization on that as we were doing in our old asset handler here. So this is actually literally kasset shader serialize and deserialize. So I think the only thing we should have to do is include a file here, and then we have to change the function signature on this to use the specific asset type, which means we'll also have to do that in the C file. Serializer, there we go. Oops. And I think that's going to be probably the only real issue we have in this file. I think that should be fine. We're still doing sort of the unnecessary cast, but I'm not really going to worry about that for now. Okay, so that is that. We deserialize that, the shader asset. Now we need to actually go into the type itself. And again, we want to remove this base kasset thing here, and we want to do a kname name. Right, so we have that. And then I believe the only thing that we actually need to do is add these functions to the header. And we are all set for this, I believe. So let's just grab this, go down here, go to the header file, and we'll just change these to be the declaration. And I think I think that's all we have to do as far as the asset handling stuff goes. And then from there, it's going to be just a little bit of work in the... Oh, looks like we missed something in the serializer. Serializer shader. Serializer. What did we miss? Oh, I bet it's the name, isn't it? Because we used to have the base meta for the name. We don't have version either. All right, we'll add version to it as well. Actually, that seems to be the only thing that's missing in here. Okay. Let's go ahead and just add, I don't know, U32 version. Okay, now we just need to update the resource handler for the shader. Okay, so Singy, good to see you over on the YouTube side. How are you doing? I hope all is well. All right, so let's see. This was... Right, I had forgotten that we had this bit. All right, so let's close that. We don't need that buffer. So the way that this worked for shaders is we could either provide an asset path or we could provide shader source directly. And that's because some of our default shaders can actually provide the shader source in code. And that way we don't have, just shader code floating around for some of our default shaders. These are shader config files, by the way, not necessarily the actual GLSL themselves. So for like our default material shaders and stuff like that, they would go this route and use the source directly. So this just needs to be, I think this just needs to have the cast removed, actually. Because that is just using the direct type instead of casting it to a K asset. So that is fine. The big thing that we have to fix is basically this, right? So where we're using the old asset system request with a request info, we don't have to do that anymore. We can simply perform this logic and then do the stuff that is in shader K asset on result, which essentially is kind of the same thing before. If the asset loaded successfully, then we just do asset to resource, right? So really we just need to hoist all of this logic up into our single load call, because we don't actually need to do all of this stuff anymore. So actually I'll do this below this actually. So what we'll do is we'll say K asset shader asset equals shader system, and then wait a minute, not shader system, asset system, you dingus. Let's see, request shader. Let's see, should we do from package? Yeah, we should do the package version. Okay, so the state is going to be, I think, self asset system, and then package name is going to be invalid K name, which actually, doesn't this actually require string? I think it does. So we hard coded this. Okay, we'll just have to fix that later. That's fine. I can use that for now and then do, let's see. It's going to be resource name, but we're going to have to extract the actual string from that, the C string from that. All right, so this is going to give us our asset, right? And at this point, we can say, if no asset, because it failed or whatever, failed to load shader asset. And I guess we could just say that C logs for details. And then we can do essentially just a copy of this. And that will be a return false. All right. So what we do now is we take all the stuff from shader k asset on result, and we want to go to asset to resource essentially, and we're going to take essentially all of this all the way down here, and we're going to hoist all of this stuff up and do this in line right here. So we'll just paste that there for the time being. We can get rid of all of this stuff, right? And then out shader resource is actually just going to be mapped over to resource here. So the way that we're going to do that is I'm going to say, let's see, let's do out shader resource, right? Actually, we can't do that because I think I'm going to want typed resource, actually. Okay, I guess I will do a find and replace here. Out shader resource, and then it's going to be typed resource across the board. All right, and that will, of course, obviously done this bit at the bottom, but this function is going bye-bye anyways. So we're going to delete that. We're also going to delete that. Go to the top here, delete these two, get rid of these other references that we're not using, and oh shoot, we do have another asset to resource. I do need to keep that then, actually, in this case. I forgot about the source path. Okay, not a big deal. I can just undo this. So this function can still go. That can still go. We'll keep asset to resource. And then instead of this, instead of all of this stuff, including that actually, we'll do asset to resource. So the asset is going to be just asset, and the resource is going to be typed resource. Does that return a Boolean? I forget. No. Okay. So actually, that should do it. Looks like we've got a couple warnings here. Oh yeah, it's these guys. Okay. Okay. So now we're to the render graph, which is actually using. Oh, the render graph nodes are actually using textures. Perfect. So I forgot about those. Okay, not a huge deal though. We can change those up. Let's see. Let me just catch up with chat. If you guys wouldn't mind keeping that to English so I can understand it, that would be awesome. Hello to all of ours is what I'm getting from that. Yeah, so if you guys wouldn't so I don't have to run it through Google Translate, right? Because I can't read Russian. Yeah, I appreciate you guys, but yeah, if you could keep it to English, I would greatly appreciate it. First time chatter, welcome, by the way. It's not like a bannable offense or anything if you guys, as long as you guys aren't like, you know, causing chaos or anything. But I just prefer you keep it to English in the chat if you don't mind. All right, so forward render graph node. Let's take a look at that. This is bleating about the irradiance texture being set. Simple enough. So wherever we have these K resource texture pointers, we're actually going to need to change that to just be a K texture, right? So not a big deal. Let's go to the C file. And I'm sure there's going to be other places that are going to have this wrong, and that's okay. So anywhere that we have anywhere we have one of these, we essentially have to just change it over to be a K texture, right? And this is going to be a K texture array, so we do need to keep that. This is going to be K texture. Whoops. Let's see. An array of K textures, right? Not an array of K texture pointers anymore. Let's see. Texture system. I think we had acquire. Didn't we? Or texture acquire, was it? Yeah, texture acquire. So image, asset, name, listener, and a callback. So this is during the initialization. So we actually want to use the synchronous version of this here. Because it's during initialization and we absolutely need some sort of default resource here. That's essentially what all of these are doing. This is all default resource stuff. So we want to use the synchronous version for that. Thank you for the follow. Appreciate that. Welcome. Okay. So let's see. Shadow map. Okay, I think I already got these. Internal data, shadow map source, value T. So the render graph source is actually going to have to change too. So instead of a struct K resource texture, which we can actually get rid of, this is just going to be K texture T. I don't know if we're actually doing that anywhere else in this file. I don't think so. I think it's just that. So this is for hooking up sources to sinks. Picture system, acquire cube. So this is, again, the default sync. Or was it? I think it's just... Actually, I think it's cube. Acquire sync, I think. Or was it acquire cube sync? Oh, texture cube map acquire sync. That's what it was. Eventually, this will become second nature. I just don't have it all memorized yet, right? So all this one requires is just the image asset name prefix. And then it generates everything else from there. I actually just had a thought, though. Where we're doing this, I think... Is that using K-names? Yes, it is. Okay. All right. So we're good. So this is all we're going to need is just going to be that. So all this stuff can go bye-bye. So see, that's much easier to use, right? I think, anyways. So IBL cube textures is going to be an array of K textures, not pointers anymore, right? So that's that. Render water planes. So this is going to be... I'm actually surprised this isn't static. Yeah, it's only used in this file, so why did we not mark it as static? We probably should have. All right, we also need to figure out some of this stuff. Let's see. So internal data color buffer texture. So our internal data structure also has a couple of these things. So this should be just a K texture. And this should be just a K texture. I thought I had gotten them all, but apparently not. Did we have that structure forward declared anywhere? No. I see the skybox file has errors too, so we're going to have to go into that and fix it. Anywhere that we are using sort of this old K-resource texture, we're going to have to fix that. Because now it's just K textures everywhere. All right. And that actually includes the renderer front end. Render scene is going to be the same concept. So why was that not static? Oops. I don't know, but now it is. So we have that. All right. So this is going to be one of those rare scenarios where we actually are going to need to call out to our texture system to get the width and the height of an image. And if you recall, I said that this was going to be somewhat rare, but not completely out of the question. So let's go back to our texture system because we have not set this up yet, actually. So let's see, what things are we going to need? We're going to need the width and height. We are also going to need a way to get the render texture handle. So at a minimum, we'll implement those, and then we'll kind of come back here. So texture system. And I guess I'll put all this stuff probably at the bottom after all of the other stuff, right? So we'll do a couple things here. I guess I'll do a U32 return type. We'll say texture width get, right? And that's going to take K texture T and just return a width, right? We'll do the same for height. Pretty self-explanatory, I think. And then we'll also have one that does both. So KAPI, and in this case, we'll have this return a Boolean, right? And we'll say texture width, actually we'll say texture dimensions get, right? And we'll do K texture T, and then we'll do a U32 pointer out width, U32 pointer out height, right? And then we also need the handle, right, to the internal sort of resource there, which actually, why do we need that? Come to think of it. Renderer begin rendering. Why does that actually require? We should be able to just pass that. Well, no, I guess not, right? We don't want our renderer to have to worry about textures. Or maybe we should to simplify the API. Because the way that this works right now is we just use all the internal handles for everything. which is fine. It makes it quick for the renderer to look things up, and it also prevents us from the renderer having to reach out to the texturing system to do that lookup. Yeah, let's leave it that way. Okay. Let's see. Mutant Spew. I love the name, by the way. Thank you so much for the Prime. I appreciate the support. Thank you. And welcome. How are you doing tonight? Very much appreciate that. Okay, so I guess we will do... Oops. I guess we will do a... How did I... There we go. So we'll say khandle. And we'll do texture. Renderer handle get. Ktexture t. That's all we need for right now. We may need... We're probably definitely going to need other functions as we go through this, but for right now, let's just implement these. So we'll put all of these right here. All right, and we'll have to do a little bit of checking here. So we'll have to first say if t equals invalid ktexture, which is basically 0, right? I think, or is it invalid ID? I forget. It is invalid ID. Okay, so if it's an invalid texture, then we're just going to return 0 for that, right? Otherwise, we don't have the texture system state, and we need that. This is something I've been rethinking about too, is like having to pass the state all over the place kind of sucks. But a lot of our systems work that way. And it's easy enough to get from anywhere in the engine. We could just do engine systems get, but I suppose we ought to fix that, right? How does this texture resize work without it, actually? Oh, because we're using... I forgot about this. We do have a fix me to remove this. Because we do keep a static pointer. I wonder if we ought to switch back the texture system to use the static pointer instead. Because for singleton systems, as we call them, right, we're not going to have more than one of these things, so this is technically not terrible. It does prevent us from hot reloading, but I don't foresee us actually hot reloading the engine, which is why I was thinking of switching away from that in the first place. All right, so I guess what I'll do, we'll just utilize that for now. State pointer, and then we'll do, let's see, we want, renderer texture handles, that's what it was. Sub T. Let's see, is that should be. Why is that warning me? Oh, because I didn't type return. That would be why. And I did the wrong thing here. This is actually for this. Okay, and this will wind up being k handle invalid. All right, so essentially it's going to follow the same pattern for all of these things, right? This is going to return 0, and then this is going to do, I guess, widths sub t, and then this will do heights sub t. And then this will do both. The only difference being this will return false. This will return true, right? And then we can just say out height is equal to that, and then do the same for width. So out width is width sub t, right? So now we can use this in lieu of having to, pass that huge struct around all over the place. Keep us from having to pass a whole lot of data around. So what we'll do here, and actually I can get rid of that buffer now. What we can do here is, let's see, do we need the width and height anywhere else in here? No, we don't. So we can localize it to here. So we can do a U32 width height, right? And then we can do texture dimensions get. The texture that we're going to use is color. And then we do the address of width, and we do the address of height, right? And I guess, actually, if this fails, I guess we could return false, right? We weren't actually even checking that before. So there's something to be said there. Okay, so this is color width and color height. Okay, that should be fine. So we just remove this, right? And then we could just do width and height. And I know there's a couple of other places in the code base we're going to have to do that same thing, but this I think is much easier, or far better anyways, than passing a huge struct with a bunch of texture information around it when we normally don't need 90% of what's there. So the only other thing that we're going to need is begin rendering, and this is going to want a render texture handle for the color. So we're going to do k handle, and we'll do color handle, and that's going to be equal to texture render handle get, and that's going to be color, right? And then we could just do color handle. Okay, so there's just a few more places that we're going to obviously have to fix this, right? The shader system, actually, I think in the shader system we did the interface level change. Yeah, we did. I don't think we did the C file change for that. So this is kind of what we're going to be doing in this stream, I think, is just kind of going through and fixing issues like this. This is internal SB cube map. So I can guarantee that's using the wrong type still. So for the skybox, that's probably what this issue was all the way at the top here. Yeah. So if we hop into this file real quick, we'll just fix this here. So this should just be k texture cube map. And I think that's actually all that we need for that. I'm sure the C file is probably going to need more attention, but that's fine. Okay, so that works there. Begin rendering. Okay, so this is going to be, again, the same thing. So we have color and depth. So now I'm actually thinking where we did this, we should probably hoist this up further and do this up here. Right? So that's going to be color handle, and then we need depth handle. Right. And so now we can just do color color handle, depth handle. Much easier to work with. Okay, so let's see. Irradiance maps provided by probes in the world. Okay, so we still haven't actually like set this up properly. It's still kind of a hack. But this is now just going to be K texture. It's going to be a K texture array, right? So we're just zeroing that out. In fact, don't we actually have... I thought we had... I guess not. I was thinking that we actually had a function for this, but I guess not. Like our K-alloc type C array, like that whole thing. I could have swore that we had something in here for zeroing an array. You have realloc, copy array. We did not do it for zero array. Okay. Suppose it doesn't matter. We'll just do it this way. Okay. This is all the terrain crap. We don't need that right now. Let's see. Okay, so material texture gets. I think our material system has been updated, so that will give us everything we need here. So these guys just need to be K textures. And then we need, let's see, we do need the handles for those guys. Yeah, so let's go ahead and grab those. I guess we'll do these in order, right? So we do refraction, then reflection. So we'll do K handle. We'll say refraction color handle, right, is equal to texture render handle gets refraction color. Nope, that was reflection color. I'm going to have to watch that. Okay, so we want depth, and then depth, and then reflection, right? And then this is going to be depth and depth here, and then this is also going to be reflection. All right, have I done that right? So we have refraction color, refraction color, refraction depth, reflection depth, reflection color, reflection color, reflection depth, reflection depth. Okay. So these are actually going to be the ones that we're going to want to use. So the way I'm going to handle this is just do handle, right? I keep typing the wrong thing. Handle. All right. So that's that, and then it's going to do the same thing down here. And since these are already named correctly, the autocomplete just works. Okay, so those are the reflection and refraction and reflection textures being cleared. So those are fine. We're also going to need to do the same thing here to both of our colors, and then just the depth. We're going to have to prepare them for sampling, which basically is our way of saying we need to transition the format under the hood in the Vulkan backend. Nivimi, have a good one. So this is going to be that. And now we need the flags for those things. Okay. So we need to be able to retrieve flags. So I think that is just, did we actually type def something for that? I forget. K-texture flag bits. Okay. So we need KAPI, K-texture flag bits. And we'll do texture flags get K-texture T. And we'll go down here to the bottom. Oh, I guess we won't go to the bottom. We'll go right after this. All right, that's going to be the same pattern as we've done before. I might actually make a macro for that. So if we don't have a valid texture here, we're just going to return 0 as the flags. And then if we do, we're going to say, we're going to say flags sub t. All right, so now I guess we can go up here. Let's just do all of the retrieval in one spot, right? Because actually, yeah, let's do all the retrieval in one spot. And I don't think we're actually going to need all of these. I think the compiler is probably going to bleat at us, but what I'm going to do is I'm going to comment them out, the ones out that we don't use. So we're going to go K-texture flag bits, refraction, color flags equals texture flags get refraction color. Right, and we'll just kind of do the same thing. So this is going to be depth, and then this will be depth, and this will be depth, and then this will wind up being reflection, and reflection. All right, and then we'll just have these down here where we can say that. Let's see. Never ceases to amaze me is that people continue to write inefficient programs and see how many branches did you... I assume you mean branches. Did you do to find out the size of the texture? 3 or 4 branches for every sneeze kill performance. If you're writing C++ or another language with exception support, there would be exactly 0 branches. Blah, blah, blah with width and height. My texture size. Cyclomatic complexity is through the roof. So what you're saying is me getting all of these flags or doing all of this stuff, right? And doing this check is wholly inefficient, which you're not completely wrong. And this is why I was talking about maybe making a macro out of this, because really in a debug version, we're going to want to do this. But in a release version, we're probably not going to want to do all of this, right? Because in release, we know we're not going to have to, we're not going to be passing invalid textures around. So in release, we could very much just eliminate that entirely. And just have it just do this. The reason that I'm doing this is because this way I don't have to pass around a huge structure full of a whole bunch of data having to do with textures when we almost never actually use that. And so this way I can actually only grab this information when I actually need it instead of passing a huge structure around. These K textures are nothing but IDs, just a U16. So there is, eventually your hands will get sore from all the useless checks. Yeah, so like I said, these aren't useless yet because I'm refactoring this stuff. This will eventually, like a lot of stuff like this is going to be going away in release builds. And in fact, like we have a lot of assertions and stuff that only happen in debug builds, and this is probably going to be an example of that as well. It's just while I'm writing this out, I need this stuff in there to make sure that I've actually done it correctly, since I'm refactoring all these systems, and then I'll go through and remove a lot of this stuff. Happy Rosenrot. How's it going? First time chatter, welcome. All right. So this is also using the old structure. So we used to actually pass around these structures, right? Everywhere. Pointers to these structures all over the place. We're just passing this stuff around. And there's no need for that, right? We can actually just do a simple lookup if we need that data. In this case, all it is actually doing is setting an internal ID, right? So like we don't need the entire structure for that. We can literally just set what we need here and forget it. Probably what I might wind up doing too is instead of retrieving the handle all the time, I probably will wind up caching it, right? So I'd cache the handle probably ideally here instead of actually retrieving it all the time when I go to render. In fact, I might actually fix that now. So we're just setting the 1, which is fine. We're not going to be increasing that anytime soon, but we probably could cache the handle here as well. I'm just thinking if there's any reason we don't want to do that. I cannot think of one. Honestly, you know what? I'm not even going to bother because a lot of this render graph stuff is going to be going away anyways in a future release. So a lot of this complexity that's in here is actually going to go away. This was sort of an experiment that we were trying out anyways, so I'm not going to worry about it for now. Okay, I think we've figured out everything that we need to figure out for that. Clear depth render graph node. Okay. So once again, we have some stuff using the old structure. So we need to fix those. So this is going to be a K texture, if I can spell. What are you planning for the future? Well, how's it going, Magats? Did you just get in here? So I assume you're talking about the render graph stuff, right? So if you're talking about yeah, okay. So actually the render graph stuff is going to be going bye-bye completely. So it was kind of a cool experiment. I liked it, but I didn't like the complexity that it introduced to the code base. So I'm going to be eliminating that, and we're going to be just doing direct render calls in the application code. I want to keep the engine, I want to go back to keeping the engine sort of lean and mean, but we're also going to be moving the concept of a scene to the application code as well. And so the scene is also going to be responsible for setting up how this stuff should be rendered, because the scene actually is what has context about what should be rendered and when and all that other stuff. And trying to sort of take all that context out of the scene and hand it over to the render graph every single frame, and then having the render graph construct and build up all of its command lists to fire off to the renderer, and doing all of that every frame. Yes, it's more generic, but it's a lot more convoluted, a lot more code, a lot more overhead, and I just want to eliminate all that stuff. So we're going to actually be eliminating the render graph in the future, in the very near future. Kuju raiding with a party of 44. Dang. Thank you so much for the raid. I appreciate that. What did you get up to on stream? Welcome, raiders. if you guys aren't following Cujo, definitely do it. He's working on a game called Fat Goblins that is written in Jai, and it's looking really sweet. It looks so much better every single time I'm able to tune into one of his streams. So definitely check that out. Forced death voice chat with pitch shifting. Oh, that's awesome. I like that. That's pretty sweet. I'm gonna have to watch the VOD on. Did you get it done? Did you get it working? Because yeah, I'll have to check that out. Works, but the pitch shifting quality isn't great, and I have to wrangle Fmod to do positional. Oh yeah, ooh, good luck with that. I'm eventually going to be doing some pitch shifting stuff in my audio plugin as well through OpenAL, so I'll let you know how that goes. Although it's not voice chat in my case, it's just going to be pre-rendered sounds, so maybe not as complex. Today was just pitch shifting. All right, awesome. Well, that's pretty sweet that you're going to have voice chat in there, though. If you have an idea of what library to use or pitch shifting, let me know. Quality is so bad. Yeah, I haven't actually done it yet. It was one of the things. One of the things I want to implement is pitch shifting for things like when you're crafting. Maybe the sound of a hammer or something like that, randomizing its pitch every single time it pings and that kind of thing. If it's not real time, there's good options. Yeah, I'm going to do it the hard way and do it from scratch. Using OpenAL, but writing sort of the logic around that from scratch. So we'll see how that goes. Yeah. Yeah, I don't know how that's going to go. We'll see. But I'll let you know. Magetz says, gotcha, fences, barriers, and semaphores. Here we come. No, all that stuff actually is abstracted. The front end of the renderer doesn't know about any of that stuff. So, gonna head out though. Good luck with the rest of your stream. All right, I appreciate it. And again, thanks for the stream. I will see you later. What I'm gonna do is just give a quick and dirty intro to what we're doing here to all of the raiders. So, welcome raiders. What we are working on is called the Kohi game engine. I'm dropping a link there in chat to the website we're looking at now. This is sort of the central hub for the project. So. This is a game engine that is written from scratch in C using Vulkan as its initial rendering backend. I say initial rendering backend because we do have support for Direct3D and Metal planned as well. So it started off as sort of a tutorial series on YouTube, and we quickly outgrew that format because that only works so far when you're talking game engines. And so we've tried a bunch of different things, different formats, and we finally landed on the live stream format that you see here. So we do stream on YouTube and Twitch. The engine itself is free and open source. I already actually have a tab open. So it is available on GitHub. It is very early days, so I don't necessarily suggest anybody uses it yet. We're still very much changing things, and the code base is pretty volatile at this point, but it is free and open source and always will be. It is Apache 2.0 license, which means you can use it either personally or commercially. It does not matter. All that I ask is that you say you use it if you do. That's it. There will never be any sort of licensing or royalty fees or paywalls or any of that kind of crap for the engine itself, because this is designed to be an educational exercise, and I believe that stuff should be free. I don't have any sponsors aside from you guys via like Patreon and that kind of thing. That stuff is entirely optional. None of it is paywalled. I will not be paywalling anything having to do with this engine. In addition to that, we do have a Discord community over, I think it's over 1,000 people now. There's additional links here to the YouTube and Twitch channel and GitHub and all that good stuff. And of course, the stream is down here at the bottom where I can wave to myself in perpetuity. And there we go. So with that, what we are working on is, and I just have a very, very rough document here. We haven't gotten very far as planning, but we do have some stuff. We're working on a 3D isometric action RPG using this engine, so that's going to be the first game that is using this engine. And so the way that we're doing this is we're doing a little bit of game dev until I find some stuff that I need to tweak in the engine. Then we jump back to the engine, make those changes, jump back to the game code. Since this is a brand new engine, we've just started, we're probably going to be spending lots more time in the engine than we are in the game code. But while we switch back and forth, eventually we're going to be mostly on the game side. So we've already gone through and done, a little bit of overall, high-level design on how we want the game to go. So it's going to be pretty much open world in such a way where it encourages exploration, so that we don't have too linear of a path to get from the start to the end. There will be multiple endings, though, based on some of the actions and choices you make. As far as progression, there's not going to be your typical experience points or anything like that. Progression will be basically through gear and stats, essentially. So we're not doing levels or experience or any of that stuff. And so we've got a whole bunch of lore background that we've written here. I'm not going to go into that now because it's kind of involved, actually. But we've got a whole bunch of stuff planned in terms of some various mechanics, like inventory, ability or skill tree, maybe, items, resources, attributes, progression, different item types, all this kind of stuff, right? Combat mechanics, things like that, control schemes. So we've got, a decent amount in this document, but for now, what we are doing is we are actually reworking the way that our assets and resources are handled within the engine to simplify them, because the current system is a little bit clunky. It was designed to be super generic, and I think it was designed in a way where it's generic to a fault, in that it's actually kind of difficult to maintain. And so we are actually going through and streamlining the API to make the API for loading assets and eventually resources much leaner and easier to use. And also, we're going to eliminate a lot of code as well. So that is kind of what we're working on at the moment. Hope all that makes sense. Yeah, that's the 5-minute spiel, as it were. So what I'm doing now is I'm kind of stepping through. I've actually got, I think, all of the asset level changes done. And now I'm going through the engine and changing all the bits that this stuff touched in order to actually bring the rest of the engine code up to date with the new system. So let me actually just build this real quick to see where I was. So render graph C. And so our render graph, the render graph that we have right now is actually pretty open-ended and highly generic as well. But as I mentioned, there's lots of overhead with that. So in a future stream, we are actually going to be going through and removing the render graph too. Let's see. So I see we have a struct k resource texture here. So I thought we got rid of a lot of those, but apparently not. We got rid of the forward declaration. So let's just do k resource texture. Actually, let's do a. I don't know if I want to do a find and replace on that though. So instead of taking a struct texture everywhere, we are now just dealing directly with k textures, which is just a U16 unsigned short. And so instead of passing around a structure or a pointer to a structure that contains all this data, which we almost never actually need, we've converted our texture system to be a little bit more streamlined in terms of how the data is stored. And so we've internalized all of those basic texture properties into a structure of arrays. And those arrays are indexed by this k texture, which is essentially an ID, which is an index into those arrays. And so we are sort of just kind of working our way through changing that as well. So, and I forgot the struct. So we have k texture. And then, let's see, do we have any other? Nope, I guess that's it. Okay, so let's build again. All right, clear depth render graph node. So let's go ahead and fix the issues in here. So we've already fixed our source structure for sinks and whatnot to use K-textures, but there's going to be lots of internal data structures that are going to still reference the old way of doing things. So we just have to swap those out. Let's see. Clear. Okay. So this is something where we have our buffer texture. I don't think this is ever going to change dynamically. Every part of me wants to cache this, but I don't think I'm going to bother because, as I mentioned earlier in the stream, all this render graph stuff is going to be going away. So I think I'm just going to fetch the texture handle inline here, which I would never want to do if this was going to production, right? But since we're going to be removing this anyways, I don't really care. So we'll do a K handle, and we'll say, let's see, let's just call this handle. I guess it's fine. And then we'll do texture, render handle get, internal data, buffer texture, right? And then we can just simplify this to handle. So for clarity, what this is this is getting the handle into the renderer backend texture data, right? And then that gets passed on to the renderer, and that is how the renderer actually interfaces with the texture, right? So the renderer, the texture system has its own representation of the texture that is handle driven or ID driven, and then the renderer has its own internal representation of the texture that is handle driven. And they match based on those IDs that is within the texture that is retrieved here. And so those two sets of resources are completely separate from one another, so that the renderer only has what it needs to know about, and that's contained within the renderer, which is all of the API-specific stuff, like the Vulkan image and all that kind of stuff. And the memory associated with all of that, right, or to be... when we go get ready to do, OpenGL, if we do that, it would be just a singular ID, or the metal data or the data for Direct3D, whatever, right? And that way, our stuff external to the renderer doesn't have to worry about it. It just has a handle to it and says, hey, look up your data internally. Let's see. Having those custom data structures is very impressive, and embedded comes in handy. Those are my favorite little projects to implement. Yeah, definitely. Things like handles and whatnot, for sure. Is that some sort of modular architecture? So the way that our renderer works, for example, is we actually have a what I call a renderer front end and a renderer back end. And so the front end is the rendering API agnostic code, right? So it doesn't care whether we're running Vulkan or Direct3D or Metal or whatever. It doesn't care about that. It's only the stuff that the rest of the engine cares about, right? So it's the interface point to the rest of the engine. So the engine itself only knows about the renderer front end. And then there's the renderer backend, which is where all of the API specific stuff is handled. So that would be all your Vulkan logic or all your DirectX logic or all of your Metal logic, right? And that is implemented as a plugin. So the application can decide what backend do I want to use, and you can even adjust that. You could change it via application settings if you wanted to. The application could hard code it. You could do any number of things with it, right? It's completely flexible, and the application can choose it. You could vary it by platform, which is going to be necessary, right? And so you can say, if I'm on Linux, use Vulkan. If I'm on Windows, use DirectX. If I'm on if I'm on Mac OS, use Metal, for example. And so, you allow the application to specify that, right? So the renderer backend is a plugin. And so whichever one you happen to load up, that's the one that, is referenced from the renderer front end. Our audio system actually works the same way. We have an audio front end and an audio back end. The audio back end that we have right now is OpenAL, but you could also use Fmod or something like that if you wanted to. So as far as state is managed, so it varies, right? So the engine essentially has, in fact, so we actually have this this engine thing here, right? Which we have this gigantic struct that holds a bunch of states, right? And we actually have a function that is statically available for us to be able to get memory for this particular system. These are all forward declared structures for each of the individual systems that we have in the engine, right? So from here, you actually have no idea how large these things are, right? So we store a memory requirement for that, which each system is responsible for knowing how much memory it needs. And then the engine allocates enough memory and sticks that here. And all of this is allocated out of a giant arena that the engine sets up on initialization. So it's all one giant chunk of memory that could just be passed around as necessary for the system state. And then the actual application state also is provided its own version of this, and it can tell the engine how much it needs, and then the application can manage that on its own as well. So yeah, it is global, but you can also pass it around as necessary. So yeah, I hope that makes sense. There's one giant state, but then there's also, within that giant state, there's also all the little states for all of the various systems. And then it's up to those individual systems to manage their own state. Thank you for the follow. Appreciate that. All right. Let's see. Where was I? Okay. So it looks like we finished this one. We need shadow render graph node next. Shadow render graph node. Let's go into the C file. Okay, so we don't need K resource types anymore. All right, so for the shadow, we have the depth texture, and then we have the default base color texture that's used for it's used for all of our non-transparent materials, right? So this is just going to be a K texture, no longer a pointer. This is going to be the same thing, no longer a pointer. That's just going to be that simple ID. And then we just need to fix the references within here, which is going to be, let's see. So we're setting up our default, we're setting up our defaults here. So we need to switch from the old texture system request to texture acquire sync in this case. And we can actually remove, all of this stuff, right? So that synchronously obtains a reference to that texture, which we know is already going to be available by the time we get here. So that'll be an instant return anyways, but we want to ensure that. Texture system request depth arrayed. Now, this one is going to require one of our special, texture acquire with options. And so we're going to have to fill that guy out. This is going to be a little bit more complicated. I might eventually add sort of a way to just do it like this, but there was a lot of properties being passed here, right? So let's see. If I can just... I'm just looking at the old function definition here for a second. So we want, which one were we using? We were using request depth arrayed. So the only reason I'm pulling this up is because, is it here? There it is. Is because of the order of the properties, right? And this is one of the reasons I switched away from doing it this way. It's because it was kind of hard to keep track of, right? Okay. So all of these properties here are essentially that. So I know how to translate that when we go to request this. So we'll do k-texture load options. And then we can set this up and say, let's see. So we want to say is depth is true. Let's see, include stencil. I don't think we were including the stencil, so we want to say is stencil equals false, even though that's the even though that's the default. What did I hit? Here we go. Even though that's the default, I still want to kind of be explicit there, right? So we want to do name is equal to this. Let's see, the resolution, so the width is going to be equal to this. And the height is also going to be equal to that. So I'm just going to do this. And then let's see. I think that's going to be array sizes next, which is this. Let's see, not pixel array size. Layer count. It's going to be this. Let's see. Do we need? Oh, we also need multi-frame buffering, which I think was true. Yep. So multi-frame buffering equals true. All right. Let's see. We also need a couple of other things that aren't specified here. So we need type is equal to k texture type 2D array actually. I think that might be it. All right. So now we can actually say here. We want to say texture acquire with options sync, and we want to just pass options, right? Okay, I think that's all we need to do there. So I can eliminate this. We don't need that anymore. Okay. So essentially we just fill out this structure, right? So if we need some sort of super specific texture with very specific requirements, then we have this to fall back on, right? So most of these, texture acquire or whatever, has one of these defined internally, and it just sort of uses a default set of settings here, right? In this case, we're essentially just saying we need something super custom here, so here we go. So that's that. Why is this indenting funny? Let's see, why is that closing here? Where did the end of this go? Did I remove? Let me undo this for a second. What did I do? must have deleted a curly brace somewhere. Oh, right here. Okay. All right. So here's an example where we need to actually execute this stuff. So just like in the last render graph node, I could cache this handle, right? But I'm not going to, because eventually we're going to be nuking this stuff anyways. So when we convert this to run in our actual application code, I will do caching of the handle, but for now I'm not going to worry about it. So what I'll do is I'll do it right here. So khandle, and we'll just do depth texture handle equals texture render handle get, and that's going to be internal data depth texture, right? And then here I can just do depth texture handle, and it'll be the same thing here, right? Okay, so we just got a couple more things to figure out here, I think. Yeah, okay, so we just have to convert this one too. Let me catch up with the chat real quick. Nice. Was the Quake Arena engine have a similar architecture, looking at the global local variables to understand whole modules? Oh yeah, so actually that's where I got the idea from. The front end back end thing was from I think it was might have been the Quake engine. I was thinking it was the Doom 3 engine, but I think the Quake engine did that first, maybe. But yeah, that was where I got the idea for that architecture. Was I actually was reading through that blog about by Fabian Sanglard about that renderer, and I was like, that's a really good idea, and I kind of implemented it and stuck with it, and it's worked really well. Was looking at the Quake Arena engine source code. Yeah, pressed enter too fast. Fair enough. One of the ifs is missing a closing brace. Yeah, okay, I did find that, but thank you. Yeah, I do that sometimes. Sometimes I'll accidentally delete something and I'm like, why? But why? Okay, so base color. We want to bind the appropriate texture. I guess that was just swapping the type, right? So in this case, we can't really... oh, did we change that? Uniform set by location value. Don't we actually have texture set by location? I thought so. I think this was written before we actually had this texture set by location, right? So now I can actually use this. And that takes the correct thing, right? So I don't have to, deal with the void pointer there anymore, at least for that one. Okay, so I'm just going to kind of scroll down through here manually. Let's see, what is this? That's just setting matrices. Okay. So this is prepare for sampling. Okay, so this one I am going to have to go ahead and grab. Actually, did I do the... Yeah, I already have it here. Okay, perfect. So I can do depth texture handle down here. So I can do that. I don't have the flags though. And again, I could cache this, but I'm not gonna, because we're gonna be ripping all this stuff out anyways. I just need it to work for now. So k texture flag bits, flags equals texture flags get, and that's going to be internal, or actually, yeah, internal data depth texture, right? And then we'll just do flags. Perfect. Okay. I guess the destroy is the last thing that this has to do, just to release the texture, right? So actually, I think this is just texture release is all that is now. So a little bit simpler there. And this file is done. Forward render graph node. Why didn't it catch that before? 879. Oh, right. I was saying that it probably wasn't going to find this, right? So I'll just leave it commented in case we do need it. Okay, debug render graph node. So this is one of the reasons I'm saying, like, I want to get rid of the render graph stuff, because, like, all of this logic for dealing with, you know, all these attachments and materials and shader properties and stuff is kind of spread all over these different render graph nodes, right? Which I'm not a huge fan of. I'd rather have one file that just continuously, you know, sort of in sequence does all this stuff. Games just have a ton of global and stateful things in general. Adding unnecessary boundaries just adds complexity in a C code base. Yeah, and that's actually what I'm actually walking back from by getting rid of the render graph stuff, because it's actually pretty annoying. Yeah, so our rendering routine is going to be up to the application. And what I'm probably going to do is, obviously I'll have to update the game code, and the testbed application, I'll have to update it as well. So what I might do is take the current version of scenes that we have, and just put that in the testbed and let the testbed just use that one. And then I'll take, you know, I'll develop something completely new for Shadows of Illumina. And the advantage of doing that is it will be custom tailored for that game and its specific rendering needs. Ruche, appreciate the high emote there. That's one of my favorite emotes, actually, that I have in there. I need to get some more emotes, actually. I need to add some. Thank you for the stretch redeem. Oh, I don't know if you guys heard that or not, but my spine just popped when I did that. In a good way, thankfully. Not in a way that's going to leave me, you know, crumpled up on the floor. Okay. So, let's see, where were we again? Debug render graph node, that's what it was. So this guy is going to have the same problems, right? So and then we don't need those to be pointers. And I think we just need the handles, right? Let me see, what is this? So I guess when we do... I guess I could... Do I really want to... I guess in this case, it's the debug. Nah, I'm not going to bother caching it. I haven't done it anywhere else. I'm not going to do it here. Heck with that. So we'll do color buffer, texture, handle, texture, render handle get, internal data, color buffer texture. And then we'll do the same for, oops, the depth. And then all I have to do is And I think that's actually all I have to do for this one. Clear color. Yeah, I think we did clear depth, but we haven't done clear color. So this guy is going to be another one. Actually, internal data here is just going to be, again, just the K texture. And then, let's see, we need the handle, again, buffer texture, handle, and we just do internal data, buffer texture, right? And then this should be it for that one. Okay, this is the one that I knew was coming. So our renderer front end needs some work because I know we haven't touched that yet. And I think that's just going to be mostly, that's mostly going to be just converting things that are of the wrong type, right? Of the old type. Thank you for the sub over on the YouTube side. Appreciate that. Welcome. Okay. Don't crumble. Yeah, exactly. Definitely don't want to do that. Thank you for the follow over on the Twitch side. Appreciate that. Welcome. So we'll bypass that warning for now because I think we are going to need the texture system. Wait. Is this an old left off comment that I just forgot to remove? Lol. I think it is. Yeah. It is. That's pretty funny. Okay, so I can get rid of that. This is going to be another situation where we're going to need to request with options for all these guys. So I'm going to come down here again, just to this thing, just to make this a little easier on myself. So it's going to be request writable. I just want to grab the old version of this signature here, so I know what all of these are when I'm translating to the options structure. And then I won't ever have to think about this again. Right, so we'll do one there, and this is what? Request depth, which is this. Okay. So we'll do K texture load options. And we're gonna actually have to have two of these. Well, I guess I could just do, I'll just do it this way. So we'll say type equals, and this is going to be, none of these are arrayed, these are just texture 2Ds. Whoops. K texture type 2D. It is going to be writable. So let's see, this is going to be, the format is going to be pixel format, K pixel format, RGB8, which I don't actually think, I don't know if I specified that on the last one of these that I wrote, so I may actually have to go to fix that. So width is going to be window width. Height is going to be window height. And then let's see, what are those? So has transparency is false. I think that is, I don't need that in here. I don't have to specify that. That's actually a texture flag, so I don't have to actually specify that. That's automatically detected. And then what's the last one? Multi-frame buffering is true. And then name is going to be this. Right. So this is going to be texture acquire with options, and we are going to do synchronous on that one. So it's going to be options, right? And so we don't have to worry about options being defined more than once. We'll just scope the two of these. So I'll do that, and I'll do this. And then I'll go ahead and copy this bit down here. And this one, let's see. Depth is, well, we technically don't need writable, right? It's just is depth. And then we also include stencil buffer in this. Oops, that should be is stencil. Let's see, we do window width and height. Formats, RGBA8, technically not correct in terms of the actual image creation, but we figure that out under the hood, so I'm not going to actually worry about it. Multi-frame buffering is true. And then the name is going to differ, so that's just going to be a depth buffer texture. And then this just becomes texture acquire with option sync options. Right? And that is those two. Okay. So texture system resize, this is actually just going to be texture resize now. And I think all the parameters are actually the same. Width, height, and regenerate internal data. Okay, cool. Let's see, next is going to be renderer. Oh, wait a minute. Ooh, we actually have texture, K resource texture resources acquire. We need to get rid of that. Okay, so this is actually going to be K texture flag bits. Let me go to the front end header file. Let's see, what was that? Resources acquire. We did rename it here. Okay, so we just need to remove the K resource bit. All right, we already did that in the header file previously, just forgot to do it here apparently. All right, so we pass all of this stuff over from the texture that we're trying to create, which is generally going to be known at the time of texture creation. So that interface doesn't actually need to change. However, you know what? This, I'm going to change this out in favor of doing this. I've done this in a bunch of other places just in case we rename that. We don't have to worry about that in the future. Okay, one more error. So this is render texture prepare for sampling. So this is actually just, we already changed this in the header file, just need to change there. Okay. Asset handler bitmap font. Okay, so our asset handlers can actually go away now because we no longer need them. So let's go to, let's see, do we have that in, I think it was in here. We also have asset handler types. What is in this file? Yeah, okay. Wait a minute. Asset handler request context. Okay, so actually, this can go away too. What is this? I don't think this is, yeah, that's not anything I need to keep either. That can actually go away. Okay, asset importer registry. Oh, okay, so asset imports are going to be something we have to handle as well. We're going to be okay with that temporarily speaking. We should be able to run because all of our assets have been imported, but we're going to have to rewrite the importer registry, or the importing of assets. We're going to have to actually write some tools around that, because I don't want that stuff in core or the runtime anymore. So I'm going to leave that there for now. Okay, asset types. I think most of this stuff has been straightened around, so actually we don't really need to look at that. All right. Serializers we need to keep. Did we put all of the asset handlers in the runtime? I thought we put those in core, but maybe not. Source assets handlers, here they all are. So we have, let's just kind of mentally step through this for a second. So we have audio binary, bitmap fonts, height map terrains, images. So all of those have actually been done. I don't think we did KSIN though, so I'm going to hold on to that one. So let's actually do, let's get rid of, let's keep KSIN, right? We did materials, we did scene, we did shader, we did static mesh, we did system font, and we did text. So this is the only one I think that we might not have done. Which is fine. We can always hit that one up afterwards. In fact, I might actually get rid of that as an asset type and just use text and then use a KSIN parser to handle it. All right. So when I said I was going to delete a bunch of code, I was not kidding. Let's clean and build again. Okay, asset utils. Asset handler types. Okay, so okay, asset utils. Wait, was it the header file or that was the C file? Okay. Okay, so handler types. I guess we don't need the string ID stuff either. What is all of this bleating about? Asset handler based on asset reload. Oh, okay. All right, so this was our sort of base function for asset loading, which guess what? Goodbye. More code deleted, which means this can also go. Oops. Why is it not? Okay. There we go. We actually get rid of some of these too because we don't actually need all those includes either. All right. Oh, here's another one. Asset handler KSIN. Okay. I'm not surprised because I deleted its sort of interface point. What was this actually doing? You know what? I'm going to nuke this too. I'm going to get rid of it too. Which means we can get rid of this. Thank you for the follow. Appreciate that. Welcome. Which means that can also go. Okay. Oh, I might have to actually clean again. Terrain.c. Okay, so we're making some headway, right? So our core library is now building correctly. Terrain is something that we also need to redo at some point. A lot of the base logic we can keep, but once we get layered materials, we are going to need to handle that, right? So, and terrains are actually technically height map terrains. So we actually need to rename that at some point as well, which I don't think we've actually done. But I'm going to leave it for now. That's a separate change set. Okay, so let's see. Height map asset name. So that is a K name. So what this is doing is, well, height map asset is an image asset, right? And then it's doing K asset height map result. See how many times is in the file. So once for declared, once called, and then once actually the definition of it. So we're gonna hoist this up, I think. But before I do that, let's actually just convert this like we have in so many other places. We'll do that, and then we'll do. Let's see. Height map terrain. Actually, I don't think this can be const because we actually wind up releasing the asset, and I don't think that can be const. So asset system, we actually are going to need that. So what I think I'm going to do here, and I don't normally do this, but as our terrain is being loaded, well, I guess I could do an asynchronous request here. I think that's fine, actually. Because we do have it split up, right? So let's do asset height map terrain request terrain. So it's going to be engine systems get asset states our listener. Let's see, do we have a listener? Oh, we also need a name for this. Okay, so we're going to have to do kname string get typed resource height map asset name. So we're going to need a listener. What is the listener that's actually... The listener itself is the terrain. Okay, so the listener we'll pass is the terrain, and then we need this, which I think that the parameters in this are actually in the wrong order, so we're going to have to fix that. Call back. And then K asset height map terrain asset is equal to that, right? And then we can nuke all of this stuff, right? And now our request of the asset is as simple as that. Now, what is this bleating about? Oh, right. It is complaining about that. Okay, so let me clear the highlight real quick and go to this. And I know that the listener in this has to come first. So we'll put that there. And then go down here. And do that. Okay. Now, we did have a result in here, which that no longer applies. We don't need that anymore. No height map was included. Didn't we do that? Yeah, we already did that here. Okay. So we actually don't need this. Right. And the only other thing we have to change in here, I think, is the release of the asset. So asset, height map, terrain. Release asset. And so all we should have to do there is just the typed asset. I think. Did I not get that right? Asset system release height map terrain. What did I type? Oh. That's what I needed. And actually, I don't think... So asset system state and then typed asset. Typed asset should be... Oh. Right. I'm releasing the image, not the height map asset. That makes more sense. Okay. Okay, so asset handler height map terrain, that's gone. Don't need that anymore. Cool. More code deleted. Unused variable asset. Okay. That's because that's right. So if this fails, then we still need to fall back to this. So what we're gonna do, does this actually, I think this does generate, load and generate geometry. It does. Okay. So if we don't have the asset, then we are going to do, how do I want to do this? I think a go-to statement is going to be warranted here, actually. So let's take this. Let's take this. And we'll say down here. Well, let's paste this first. Let me think about this. So whether or not, so if we don't have asset, right? Then we need to go to this down here, right? If we do have asset, we need to go to this down here. If we get an asset result from here and it's successful, then we just need to return. So actually what I think I'm going to do, instead of doing it this way, is I'm going to say if we have an asset, return true, right? That way, and then we can just get rid of this. Yeah, it's a little simpler that way. Okay. So if we have a height map asset name, then we're going to try and load the height map asset. If we are successfully able to kick off the request, even though it won't be ready yet, then we'll say, okay, the asset's on the way. We can just boot out successfully. And then this will get kicked off whenever that asset is ready. Otherwise, if this either failed or we did not have a height map asset name, we use this reasonable default and do the generate and load geometry. Yes, that seems correct. Let's see. Hello, are there any other people involved in this project? There have been on occasion some contributors. So let me pull up. Whoops. So if I go here, have been a few other people that have contributed, like bug fixes, and the largest contribution is Jad here, and they came up with the initial Mac OS backend, which I did have to refactor in order to make it sort of fit what we have going here, but the initial version of it was written there because at the time I did not have Mac OS hardware to actually port this to. So yes, on occasion there have been other folks that have definitely joined in. Okay, Skybox C. Okay, I'm not surprised to see that this is having some problems. I'm surprised this didn't come up sooner, actually. So let's see, request cube map name. Okay, so this actually, texture, acquire, wait. Let's see, we're redoing the synchronous version of that. Or are we doing the asynchronous version of that? It doesn't actually look like we cared. Let me see. Let me switch back for a second here. Because I just have to convert this to the sort of the old, from the old function called a new. So auto release, multi-frame buffering. Wait, it didn't have multi-frame buffering. Okay. And then no listener, no callback. Okay. Okay, so auto release will be true by default, so that will be fine. I guess we could use... We'll try the asynchronous version and see how that works. You know what? I'm going to use the synchronous version. If it winds up being a bottleneck, we'll fix it. But it's just one skybox that we're going to load per scene. I'm not really worried about that. That's going to be the quickest fix for this. So texture system release. I think this just needs to be texture release. And then we no longer need the cast. We can just do cube map on there, right? And then we don't need resource types anymore. Okay, asset system. Yes. Okay, so these are the other fixes in the asset system that we need to do, which is all the way at the top of the file. Getting rid of like the known handler type logic and that kind of stuff. So known handler types, all of this. We don't need any of that. I think we still do need some of these serializers. We don't need this guy anymore either. And then this whole handlers thing, that can go away. K-asset type max, what is this? I think we still actually use K-asset type on occasion. So I'll keep that, but delete the handlers array. And then, asset system shutdown, so all of our assets, I don't think we do this anymore though. That's actually an interesting point because I don't think I actually worked in the believe it or not, I don't think I worked in the lookup stuff. The asset cache, which, you know what, frankly wasn't that valuable anyway. So I think I'm actually just going to get rid of it. The only thing was I did need that for hot reloading. Which at the moment is not going to be supported, but we are going to want that back. Thank you for the follow. Sakelos Music, how's it going? Good to see you. Do you know if they're using it for their games? No. Nobody else is using this for a game yet. It's too soon. Yeah, it's way too soon. I'm using this to develop the first game that we're working on, which is going to be a 3D isometric RPG. But we're still straightening out engine level, like core engine system level stuff. So it's a little bit too soon for that. It's about to be going to bed soon, but stopping by for a short chat. Oh, nice. Yeah, I get that. Actually, looking at the time, I'm going to be going to bed soon too. Yeah, we're actually almost done for the night. So I think what I'm going to do is I'm going to finish up fixing this file, which... Okay, I'm going to do this. Asset cache not currently being written to on the new asset load logic. Need to do this so it can be undone here. Okay. Font system. Font system is the next one. Okay. So we've gone through a lot of our systems, actually. And fixed things and updated them to use the new version of working with textures, right? Let me see if this is going to be a quick thing. It may be, it may not be. And if it's not, I'm going to end here. But it might actually wind up being. Okay, so for fonts, we actually want to do texture, acquire, sync on that. Because we want them available immediately. So we're going to do texture, acquire sync on this one too. And then, is this actually still, oh, yep. Forgot to remove the pointer from there, both places. This is going to be, we're going to actually have to go to the header file for this. Let's see, we don't have, actually I might need that. Need to fix the header file too. So this is just going to be k-resource texture, or k-texture rather. Okay, so we're basically just going to use those lookups now, which is actually going to solve a lot of problems with the errors in this. Request writable. Okay, so I'm going to have to make a new options for that. So I think this is where I'm actually going to stop it. Request with options sync. Okay, so this is where I'm going to end the streams for tonight. Let's see. What is this I hear about VS going full AI? It was only one video, but they are going into some specific details regarding Copilot. I don't know anything about it, to be honest. Yeah, good question. Els Dragoon, you got me. I was just about to raid you. Dang it. Beat me to it. Yep, I was literally just about to hit the raid button. Got me. You got me. How's it going, guys? What'd you guys get up to on stream? I'll give a quick shout out. So for those of you who don't know Els Dragoon, uh, he and another dev here who I don't think he does anything on his own channel, but it's a duo that is working on a NES game using 6502 assembly. It's like full Giga Chad stuff. So I highly recommend you give those guys a follow. This is the Twitch version of an eBay snipe? Yeah, exactly. Yeah, I guess you guys owed me a couple of those, right? Oh, that's too funny. Yeah. Well, welcome, Raiders. I was actually literally just getting ready to end the stream myself. So, but yeah. Let's see. Oh, I have a couple questions on the YouTube side, though. So, what's the current state of the editor? Is there something similar to... So, the editor actually is just like in-game right now. And it's not anywhere near like solidified. It's very early days for that. And no, I'm not going to be using... any sort of image or IM GUI or any of that stuff. No libraries for that whatsoever. We make everything from scratch, including the UI. So yeah, that's kind of the deal there. Max, unfortunately, you've come in right as we're getting ready to end the stream, but hello. Let's see. No, you're on the way out. We're ready to increase your raid payload. Raid load? I'm not mad at that, actually. Raid load, if you will. Yep. Arvis, he got you on that one. Let's see. We basically scoped out a full version of the project and started connecting with all the individual bits, trying to go beyond the vertical slice to more of a full meal. Nice. That's awesome. Yeah, I'll have to watch the VOD tomorrow and get caught up. It's been a bit since I've been able to do that. So, all right. So, that is where I'm going to end the stream tonight, though. So, Raiders, welcome. We are... You know what? Hang on one second. I think I know who I'm going to raid, but I need to give him a second to spin up. Because he just pinged me, telling me he's spinning up. So, I already know who I'm going to raid. So, I will... I'll hang out here for a second until he shows up. So I guess really quickly for the Raiders, I'll give a quick and dirty intro. I guess I probably should have done this anyways, but so what we are doing is we are writing a game engine from scratch, and we are building a game using that game engine. So the game engine itself is written in C using Vulkan as our initial rendering backend. We will be eventually supporting Metal and Direct 3D as well. It is designed to be an educational resource, so it's a way to build a game engine. It's not the only way to build a game engine. Sometimes it's not even the right way to build a game engine. We try a lot of stuff on here. Some stuff works, some stuff doesn't. We do a deep dive into those things either way. So the engine itself is really designed to be, an educational resource and a step-by-step. It started off as a tutorial series. We tried a few different formats, eventually landed on live stream format that you see here. It is free and open source, so it is on GitHub. The link that I dropped in chat there takes you to this website, and you can find a GitHub link here at the bottom. The engine itself is Apache 2.0 license, which means you can use it for whatever you wish, whether it be commercial or personal. Does not matter. All that I ask is that you say that you used it if you used it, and that's literally it. There'll never be any sort of licensing or royalty fees of any kind ever. It'll always be free and open source. I do not paywall stuff on my channel having to do with the engine. I believe that this educational kind of stuff should be completely free, and thus it is. I do not have any sort of sponsors other than you guys via Patreon and whatnot. So I don't, I'm not in this for the cash, right? That's what the game is going to be for, right? When I get ready to go ahead and sell a game. The engine itself, just a couple more things about it. It is cross-platform, so it does run on Windows, Linux, and Mac OS desktop environments. We do have other platforms planned for the future, most notably mobile platforms at some point. And I also want to port this to the Switch minimally, and also eventually, I'd like to get it on Xbox as well, but we'll see how that winds up. And further down the road, probably PlayStation. But yeah, so we are using it to build a 3D isometric action RPG. We've started putting together a document full of stuff we want, including world setting, mechanics, various systems descriptions. I'm just scrolling really fast because we have tons of pages of this stuff. But we've started putting together all of our ideas on how we want this to actually come together. So thank you guys for the follows, by the way. And let me see. Looks like he's up and running. So we are going to raid. This interface takes forever sometimes. Okay, here we go. So we are going to raid Spiro. He's a good friend of mine, and he does some pretty interesting stuff on stream. So he is, he says indie vibe gaming, so we'll see what that's all about. We're going to raid him and see what he's getting up to. Again, he's just spun up, so we'll give that a chance to come out to fruition. And yeah, if you guys haven't already, I would really appreciate a follow, either on the Twitch or the YouTube side, or if you're so inclined, both. I'm trying to grow the channel, and I'm trying to reach more people and hopefully motivate them to want to make game engines, because I do believe that the competition in this space is needed. We have a few of the large engines out there, and I think we need some more competition to those. And so if we can get some people motivated for that, I think that that's a really good thing. So that's kind of the whole goal here. But anyways, I will leave you guys with Spiro. Have a good one. Thank you so much for being here, and I'll see you guys later. See ya.